So today we're going to talk about Edgenuity section 5.5, which is multiplying radicals. Its objective is to perform multiplication of radical expressions. And what we're going to see is that that winds up being, it sounds simple, but there winds up being a lot of different little things that have to happen. So we're going to start with this problem. Find the product in simplest form. And we're going to start with something that we did last time, which is the ability to pull these things apart. As long as there's only multiplication inside of the square root, you can pull everything apart into separate square roots. So I can call this the square root of 2 times the square root of x times the square root of 8 times the square root of x to the third. And then I'm going to look and notice that I've got square roots of numbers there. And so I'm going to put numbers next to each other and put them back inside one square root. So I'm going to do the square root of 2 times 8 and group them together that way. If I can take them apart, I can put them back together. And then we've got all x's, and I'm going to do the same thing to that. I'm going to do x times x to the third, and then I'm going to look at what I can do with those, okay? 2 times 8 is 16, so I'm looking at the square root of 16 there. And over here, instead of looking at, say, x to the fourth, which if you put them together, you'd get x to the fourth, and that might be good to work with, but I'm going to do it in a couple more steps because I want it to be as clear as possible. So what I'm going to do is I'm going to take this x to the third, and an x to the third doesn't do me a whole lot of good. X squareds are what do me good. So instead of calling it x to the third, I'm going to call it x times x to the second. And then I'm going to pull things apart again. So I've got this square root of 16, which we'll talk about in a second, times, and I'm going to take these two, and I'm going to put them together, and I'm going to call them the square root of x squared, and then I'm going to take this one, and I'm going to pull it apart into its own separate square root, and have another square root of x squared. Now squares and square roots cancel each other, so this square root and this square cancel, this square root and this square cancel, and then the square root of 16 asks you a question. What number did you square to get 16? And the answer is 4. So the square root of 16 is 4. In the next one, a square cancels a square root, and I'm just left with x, and same thing in the next one. So I've got 4 times x, which is 4x squared. And there we have our most simplified answer. Are there any questions? I'll pause for a moment. If there are any questions, you can put them in the chat or unmute and ask me. Okay. So there being no questions, I will move on to the next board. And we'll talk about simplifying this. And this is going to be the exact same thing, but I am going to do one thing to help clarify some stuff. So again, I've got 5 times x inside of this cube root now. And again, I'm going to pull it apart and call it the cube root of 5 times the cube root of x. And I'm going to pull this apart and have the cube root of 25, and instead of calling it 25, what I'm going to do is I'm going to say, well, let me break that down. And 25 is 5 squared. It's 5 times 5. So I'm going to write it as 5 squared. And there's a reason I'm doing that, and you'll see in the upcoming steps why that is. And then times the cube root of x squared. So now I'm going to take these 5s, and I'm going to put them together inside of one cube root. So 5 times 5 squared. And I'm going to put the x's together under one cube root, x times x squared. And 5 times 5 squared is the cube root of 5 cubed. 5 times 5 to the second is 5 to the third. Times the cube root of x times x squared is x to the third. And cube roots cancel cubes. That is, third roots cancel third powers. So now it should be very clear why I wanted to write that 25 as a 5 squared, because I can do that. And I can cancel this cube root with this cube and have just 5 times x. And so I have 5x as my answer. I'll pause for a moment to see if there are any questions. No, we are still doing class. I will adjust your attendance. I am going through section 5.5 and doing problems from it. So take a look at that for a moment and see if you might have any questions on how I did that. And if there are no questions, I'll be moving on to the next board. So here is the next board. And now we're going to put numbers on the outside. And the rules about multiplication still stand here. Notice all of this. The whole big thing is still just a bunch of multiplication. So I can still pull it all apart. So now I can say -2 times, and I can pull apart the square root of 20 times the square root of k times 5 times the square root of 8 times the square root of k to the third. So I'm going to take my numbers without square roots, and I'm going to put them next to each other. So that's -2 times 5. I'm going to take my square roots with only numbers, and I'm going to put them under one square root so that I can look at it again. And at the same time, I'm going to start trying to take out things that I think make sense to take out, which are the perfect squares. So for example, 20, I could call 4 times 5, which should make sense because 4 is a perfect square, right? It has a nice, neat square root answer. So that helps me out. I'll be able to square root that pretty easily. And then times 8, but instead of calling it 8, I'm going to call it 4 times 2, because again, 8 doesn't have a square root, but 4 has a nice, clean square root. 8 does have a square root, it's just not nice and clean. So I'm going to have it like that so I can look at it again later. So I've taken care of the -2, the 5, the square root of 20, the square root of 8. And so now I've got the k's, and I'm going to put all the k's under one square root. That's going to be k times, and again, instead of calling it k to the third, I'm going to call it k times k to the second, because k to the second, k squared, has a nice, neat, obvious answer to its square root, because the square and the square root will cancel each other. So now, I'm going to take this -2 times 5, and I'm just going to simplify that and multiply it together and get -10 times. And now I'm going to start taking out the things out of this one that have answers. So square root of 4 times square root of 4. So I've dealt with this and this because those are the things that have nice, neat, clean answers. Now, the 5 and the 2, I'm going to leave inside the same square root because square root of 5 doesn't have a nice, clean answer. Square root of 2 doesn't have a nice, clean answer. So I'm going to leave them inside that square root. Then, when looking at the k's, I'm going to look at this k times k, and I am going to call it k squared, and I'm going to separate it from the other square root of k squared, because those will have answers also. So now I've got -10 times, and the square root of 4 is 2. That is, the square root of 4 asks you the question, what number do you square to get 4? And it's 2, right? 2 squared equals 4. And then the square root of 4 is 2 again. So that one and that one. And then I have this square root of 5 times 2. I can't do anything with that. So what I'm going to do is multiply the 5 and the 2 together and have the square root of 10. Okay? Then square root cancels a square and leaves me with just k. And again, square root cancels a square and leaves me with just k. So now I've got -10 times 4. 2 times 2 is 4. So that's -40 times k, which I can simplify to k squared, times the square root of 10, which I can't simplify anymore. And so this becomes my answer. I'll pause for a moment to allow for questions. All right, so there being no... Go ahead. Okay, there being no questions, I'll move on to the next board. And now we're going to look at how to simplify something where you have to distribute. Okay, so I've got this cube root of 4, and it's being multiplied by 1 plus the cube root of 2. And so now we're throwing addition into it. And as soon as you throw addition into it, things get a little more complicated. In this case, I need to take this and I need to distribute it to both of these. Just like you would distribute if you had 2 times x plus 3, you do 2 times x plus 2 times 3. It's the exact same idea. Okay? So we're going to do the cube root of 4 times 1. Well, anything times 1 is still that thing, so that's just the cube root of 4. Plus the cube root of 4 times the cube root of 2. And I'm just going to write it like that for the moment, and maybe I'll isolate it and think about making that simpler. This cube root of 4, there's really nothing I can do with that. Plus, now, cube roots, if I'm multiplying them together, I can put them together, right? So I can call that the cube root of 4 times 2. And not only can I do that, but let me think about the fact that 4 here, this 4, let me think about that 4. That 4 I could call 2 squared. And so I've got 2 squared times 2 there. The reason I'm not worrying about it here is because I've still got 2 squared there, but there's nothing else I can do with it, so there's no good reason for me to do anything with it at the moment. Plus, and then if I multiply 2 squared times 2, I get 2 to the third. And then a cube root cancels a cube. And so I've got the cube root of 4 plus 2. And maybe I could call that, maybe I could change this to a 2 squared and call it the cube root of 2 squared plus 2. Or maybe I could even call it 2 to the 2/3. I could rewrite this as a fractional exponent. Remember, the power goes on top, the root goes on bottom, and then plus 2. And these two forms are about as simple as I could write it. You could even write it this way. Any of those is a correct answer, but you just don't know which one's going to show up. I'll pause for a moment for questions. Okay, there being no questions, I'll move on to the next board. And then we've got an even more complicated version of putting things together. However, this is still just distribution. And let me show you what I'm going to do. I'm going to take this one this time, and I'm going to distribute it to there and to there. But I'm going to take the minus sign, and I'm going to call it plus negative. You can always do that with minus signs, and I encourage you to do that with minus signs because it makes very clear what's positive and what's negative. So here's how this is going to work. We're going to have that 4 times the square root of x, and it's going to be multiplied by that 2 times square root of x plus 3 times square root of 5. And that takes care of the first distribution part. And then plus a negative 2 times the square root of 5 times 2 times square root of x plus 3 times square root of 5. And now I'm going to take these outside ones and do the distribution that we were doing in the last problem. And then I'll put the whole thing together. So that's 4 times the square root of x times 2 times the square root of x plus 4 times the square root of x times 3 times the square root of 5 plus negative 2 times the square root of 5 times 2 times the square root of x plus negative 2 times the square root of 5 times 3 times the square root of 5. And so now when I do the multiplication from this point, I am going to start combining things that can combine, putting things under the same root when I can, or when it's not possible to do any simplifying, all that kind of stuff. So like, for example, in the first one, I've got a 4 and a 2 here. And I'm going to put those together and call it 4 times 2 times, and then I've got this square root, and inside the square root I've got 2 x's, x times x, plus. Now I've got a 4 and a 3, so 4 times 3 times the square root of, and I've got a 5 and an x, and I'll put them together inside the square root, plus negative 2 times 2 times square root, and I've got a 5 and an x in the square root, plus, and then I've got a negative 2 times 3 times the square root of 5 times 5. So let's simplify some things that we can simplify here. 4 times 2 is 8, and times the square root of, and x times x I could write as x squared, and that's going to be helpful to me because the square root will cancel the square. Plus 4 times 3 is 12, times the square root of 5x. There's nothing I can really do with that, so I'll just leave it that way. Plus negative 2 times 2 is negative 4 times the square root of 5x. And that's going to be helpful because I'll be able to put those two together as like terms here in a moment. Plus negative 2 times 3 is negative 6 times the square root of 5 times 5, which I could look at as 5 squared. So then, let's take care of these square roots that cancel squares. Let's do that first. So that'll be 8 times x, because the square root and the square cancel each other and leaves me with just x, plus 12 times the square root of 5x, plus negative 4 times the square root of 5x, plus negative 6 times 5, because that square and square root cancel each other. So finally, well, I guess not finally quite yet, but next I'm going to take these two and put them together as like terms. So I've got 8x plus, and then I could do the 12 plus the negative 4, which would give me 8, and then I keep the square root of 5x. Plus, and then I'm going to do that problem right there and say negative 6 times 5 is negative 30. And so now I can start putting together things that make sense to put together. Nothing can combine any more than it is. And in fact, there's really not much else that I can do except maybe write this plus negative as a minus at the end and write this as 8x plus 8 times the square root of 5x minus 30. And that would probably be the most simplified answer, although this answer is a perfectly fine answer as well. I will pause to see if there are questions. Okay, there being no questions, I will move on to the next board. And we're going to do the same thing here. Same distribution. I'm going to take this, multiply it by both. And this one is special, and you're going to see why it's special here pretty soon. Okay? This minus, I'm going to change again to a plus negative. And so I will have that first 3, that's that 3 right there, times the 3, oops, let me write that 3 better, the 3 plus -7 plus the square root of 7 right there times that 3 plus -7 again. So I've just distributed that thing on the end. And now I'm going to go through and distribute these things. And we're going to see what we have. So 3 times 3, let's say 3 times 3 is 9, plus 3 times -7, that'll be -21. Oh, whoops, no. Sorry, it's the square root of 7, not just 7. I am so sorry. Did that twice. Okay, so this is going to be 3 times square root of 7. Well, a positive times a negative is a negative. And then it's just 3 times the square root of 7. Plus, the square root of 7 times 3 is 3 times the square root of 7. Plus, positive times negative is negative. And then I've got the square root of 7 times 7, which for right now I'll write that way. I'll just put the 2 7s inside of the square root together. So then I've got 9 plus, now look at these 2 here. Look at those 2 terms. They're like terms. They've both got a square root of 7 attached to them. And if I do the one plus the other, I've got the same numbers and opposite signs, the negative plus the positive of the thing. And so either way that you look at it, if you think about -3 plus 3, that's 0. Or if you think about the negative of the whole thing plus the positive of the whole thing, that's still 0. So that whole thing is 0. Plus the negative of the square root of 7 times 7, which is 7 squared, which equals 9 plus 0 is still 9, plus negative, and then the square root cancels the square and leaves me with 7. So I have 9 plus -7, which I could also look at as 9 minus 7. Or, here's another way of looking at it, 3 squared, because remember to get the 9 we did 3 times 3, minus the square root of 7 squared. That's an important way to look at it. And either way, you do 9 minus 7, and you get 2. So what's interesting and important about this problem is that we started with square roots. And in the end, all those square roots somehow either became 0 or canceled. And because of that, at the end of the problem, we had no square roots at all. I will pause for a moment for questions. Okay, there being no questions, we will move on to the next board. So now we're going to see what happens if I've got different types of roots. I've got a square root and I've got a cube root. What I can't do is just clump them all together because they're not the same type of root. So then the strategy becomes I'm still going to separate everything kind of as far as I can here. So I can pull apart the square roots. I can call it the square root of x times the square root of y, and it's always a good thing to pull things apart as much as you can. It's almost always beneficial to you. And then the cube root of x squared, there's nothing to really pull apart there. So I'm going to leave it that way for the moment. And then you have to start thinking, how could I do something else with this? Well, the other option is from a previous section where we learned how to write these radical forms as exponent forms. We learned how to write them without the root and write them with fraction exponents. So square root of x would become x to the 1/2 power. And square root of y similarly would become y to the 1/2 power. And the cube root of x squared would become x to the 2/3, the 2/3 power. And that is because you take this and this and you make a fraction out of them where the power is the top of the fraction and the root is the bottom of the fraction. So that's how we get to the 2/3 power. So then I'm going to take my x's and I'm going to put them next to each other. So x to the 1/2 times x to the 2/3 times y to the 1/2 power. Now the y, there's no other y's to deal with, so I can't really do much with that. But this one, I've got the same base, which means I can add exponents. So this is like x to the 1/2 plus 2/3 power times y to the 1/2. So then I want to do a little side work here, and I want to figure out 1/2 plus 2/3. Need a little more room there. And whenever you add fractions, you need common denominators. So what I'm going to use is I'm going to multiply by 1 in clever forms, and I'm going to use the two denominators to help me do that. I'll use this denominator here, and I'll use this denominator here. So what that looks like is multiply this one by 3/3, and multiply this one by 2/2. So then we do top times top, bottom times bottom, so that'll be 3/6 plus, and then top times top, bottom times bottom will be 4/6. And once I've got common denominators, then I can add the tops. So I do, 3 plus 4 all over that 1/6. And then 3 plus 4 is 7, so I get an answer of 7/6. So then down here, this becomes x to the 7/6 power times y to the 1/2 power. And that's a perfectly good answer. If you wanted to write it in root form, in what they call radical form, you could do a tiny bit more side work here and say, okay, I got this 1/2, and if I multiply it by 3/3, I can make it look like 3/6, and I can rewrite that. So I can have x times 7/6 times y, or x to the 7/6 times y to the 3/6. And what that gives me is a 6th root, and I can have x to the 7th, y to the 3rd inside that 6th root. So this is a perfectly acceptable answer, and so is that. All right, I will pause to allow for some questions. Okay. There being no questions, we will move on to the next board. And now we're looking again to simplify two things with different roots. Okay? So let's talk about, again, we're going to do the same thing. And usually the best thing to do is, again, pull things apart and write things as powers as much as you can. So instead of this fifth root of 4, I'm going to call 4 2 to the second, because that's what 4 is. And then the square root of 2, and then I'm going to write these in exponent form. So that is 2 to the 2/5 times 2 to the 1/2. And then I got to do some side work, because this is going to be 2 to the 2/5 plus 1/2 power, which is why I wanted to write the 4. That's why I wanted to write the 4 as 2 squared, because then I have the same base, so I can pull off this trick right here. Okay? So then I got to figure out 2/5 plus 1/2 in the side work here. And I'll do the same thing. I'll use the denominator, so I'll multiply this side by 2 over 2. I'll multiply this side by 5 over 5. And that'll get me 4 over 10 plus 5 over 10, which is 4 plus 5 all over 10, which is, of course, 9 over 10. So then this is 2 to the 9/10 power. Or if I wanted to write it in root form, in radical form, that would be the 10th root of 2 to the 9th. And again, either of these answers is perfectly acceptable. I'll pause to see if there are questions. All right, there being no questions, we will go on to the last board, last problem. All right. So this is pretty similar to other ones that we've done. Notice this time they are both square roots. So I can start putting things together, taking things apart in any combination I need to. There's only multiplication in all of this, so I don't have to worry about addition or distribution or anything like that. I can just start, I can pull everything apart and then put it together however I want. So that's what I'm going to do. I'll have the square root of 2 out there. And then I have the square root of x cubed, but x cubed doesn't do me any good with a square root. So let me call it x times x squared, because then I can pull that apart and have that x squared. 18, square root of 18 doesn't do me any good, but 18 is 9 times 2, and 9 is something that I can get a square root answer for, a nice neat square root answer. So I'm going to call the square root of 18, I'm going to call that the square root of 9 times 2. And then x to the 5th, that's 5 x's. So I'm going to separate that into as many x squareds as I can. So there's x squared, that's 2 x's. And another x squared will be 4 x's, and then I've got one more x for x to the 5th. And then I'm going to pull everything apart a little bit more and get one more good look at it. So now I've got the square root of 2 times square root of x times square root of x squared times square root of 9 times square root of 2 times square root of x squared times square root of x squared times the square root of x. Well, now there's lots of things with answers, right? Square root cancels a square root cancels a square root cancels a square. So now I've got the square root of 2 times the square root of x times x times the square root of 9. What number do you square to get 9? And that answer is 3, times the square root of 2 times x, because those squares and square roots cancel each other, times the square root of x. So now let me take my numbers and my single x's and put them all out front, because there's clearly nothing else I can do with them. So that's 3 times x times x times x is x to the 3rd power. And then I've got a square root of 2 and another square root of 2 being multiplied. So let me put that all under the same square root, and 2 times 2 is 2 squared. That'll be helpful. Times, and then I've got a square root of x and another square root of x, and I'll put those two together and call it the square root of x times x, or x squared. And so now square root cancels a square root cancels a square, and I've got 3 times x to the 3rd times 2 times another x. And then I can put 3 times 2 together and call that 6. And I can put x to the 3rd times another x together, and that's 4 of them, so this is x to the 4th. And there we have our last answer.